So yeah, hello and welcome to my talk, AIM Search from Pet Project to Productivity Tools. My name is Jonas and I wrote AIM Search a couple of years ago. Before I start, who of you has used AIM Search before? Awesome, cool. So yeah, for those of you who don't know it, AIM Search is an API search engine where you can find exposed values in the latest versions of all the published AIM packages. Let me quickly show you the current version. So you can search either by name or by approximate type signature. So when we scroll down a little bit, we see that it also found, for example, string to int, and so it unwrapped the int and the maybe, and made this available in the search. It has also basic support. Let me click. Basic support for type variables. So note how to map the X to the A and the Y to the B. And yeah, you can click this link later if you want to check it out. And so, as the title points out, this talk is about the history of AIM Search. And because it was actually my first AIM app, it's also the story about how I got into programming AIM. And I first played around with AIM in 2015, and we are now here in Paris. So we will have a detailed look at why and how I built the current version of AIM Search. And we will also look at the new version that I'm currently implementing. And not everything I have in mind is going to be implemented in the next version, so we will have an outlook what I imagine AIM Search could become one day. And this time in between is also somewhat important because it shaped my decisions why I implemented the next version of AIM Search. So back to 2015. I did mostly front-end web development then, and I tried to write my JavaScript in a functional style. But to be honest, that meant mostly using higher order functions like filter map or reduce. And I then found AIM, and I thought, if I wanted to go functional, why not do it all the way, pure, immutable, and with a static type system? And I had no experiences in other languages in the ML tradition, but I got quickly used to the new way of thinking and writing, and AIM made this actually really, really easy. But in my first experiments, I sometimes got stuck, so I did not find a function I needed for a given type signature. I then sometimes used Google, and Google is the API search engine for Haskell, and it's one of the main inspirations for AIM Search. And I still remember from my first search there, and you might recognize that I was searching for list.fold. So I was able to map my knowledge from array.prototype.map to AIM, but I failed to doing so for reduce. But once I knew I had to search for fold, I was able to find it on the AIM package website. So I wondered, should there be a Google for AIM? And one day, Noah Hall, he was one of the most active members of the AIM community at this time, asked on the AIM Slack if somebody wanted to build a Google for AIM, and I said, yes. So this is how AIM Search became my first real AIM project. But at first I thought it must be implemented in Haskell because all the official AIM tooling is written in Haskell. And I had no idea how to approach such a project because it was unlike anything I've ever written before, and I was used to implementing user interfaces. So I researched AIM's tooling and the ecosystem, and to get an overview of what I actually wanted and what is available. So I found that AIM has some really nice properties I could benefit from. So every AIM package you can install must be installed from the AIM package website. And it's the one source of truth. And it made it the prime candidate to get the data for the search. But what data exactly and in what shape? And yeah, the AIM compiler makes sure that every published package is properly documented. And you can try this out running AIM make with a doc flag. And let's take list.hold again for an example. So in green, you have the documentation comment, and you have the name of the function and the type signature. And the generated JSON contains the same data in a nice object. And so I had no idea how to implement the search at this stage, but I knew I did not want to have like a type-based search working on just strings, and those are just strings there. And so I dive deeper into the code of the Unpackaged website. And the front end is, of course, written in AIM, and it uses this generated JSON to render the documentation there. So I found this custom type there, and it's a recursive type describing all the possible values of the type signatures, type annotations. So there was this data structure and a companion decoder and other code using it, and I was really, really happy because I figured I could write the search in Elm itself and not in Haskell, and I had code at hand for inspiration. But how exactly code at this time for me was still a hard part. And then I found this innocent-looking function, and it is used to check whether a type signature should be rendered in a single line or wrapped into multiple lines, and it does this by recursively counting the number of characters that is needed to render a type. And this actually helped me to come up with the following function. So the distance function takes not one type, but two types and returns a float. And it compares those two types and assigns a distance to it. And the distance of 0 means the types are the same. And the distance of 1 means they are not similar at all. And before I'm going to show you how it's implemented, I'm going to show you how I'm using it. And the search uses an index, and this basically is just a big list of types, and it gets the data by getting all the documentation JSON files from the packages, decoding it, and parsing the type signature there into the type we just saw. And when the user types in a query, we also decode this query string into the type. And then we just map over all the entries in the index and assign a distance to it by just calling the distance function on each entry. And we filter out bad results and just sort the list at the end. So how is the distance function actually implemented? And this is just a bird's eye view, and it's just recursive pattern matching. So I compare a pattern match on the tuple of the two types and look at interesting cases. So let's zoom into some interesting cases. So one basic example is comparing two type variables. If the names of the variables are the same, they are equal, and otherwise they get a maximum distance. And one other special case we saw earlier is comparing types that are wrapped in, for example, a maybe type. And if the type inside the maybe equals a given type, a lower distance is chosen, otherwise just the maximum distance again. And this makes the search fuzzy. And AIM's built-in type variables, type classes are also supported. So when you compare a number with an integer or a float, it's nearly a perfect match. And the recursive example is comparing functions. So I'm calculating the distance of the inputs and the outputs and adding those and dividing it by 2. And I'm doing this that complex comparisons are not automatically penalized. And there are, of course, a lot more cases. But it's basically more or less simple a base case all the time or a recursive case when the types contain other types. So I was really happy with what I got so far. And so I implemented the first version of the AIM search inside the Unpackaged website itself. And because I was already using a lot of code from this, and I thought it would make sense in general. And I created a pull request, and other people also thought it would be a good addition. And then Evan answered on the pull request, and the emphasis is mine, and let me, So he did not like Google, and it never helped him. And he also asked about how people would actually use the search and what it would mean to writing AIM code. And he was afraid maintaining such a search. And I totally understood the maintenance concerns, but I could not really see how using such a search would lead to writing worse code. And Google helped at least me, and others had similar experiences. So, but he was right that I had not really researched how the search could help and what it would mean to writing AIM code. And this was not on my radar at all. For me, AIM search was mostly playground to get to know the language and the tooling ecosystem and the community. And Google helped me, and I blindly assumed it would help others as well. So I digested the response for a while, and it was not what I expected, but in retrospect, it was a good introduction to see how things work in AIMLAND. So not everything is just blindly implemented or accepted. But I did not want to just stop with a pull request that would not get merged. So I created the standalone version you just saw earlier. And someone then made a pull request to add it as a link to the package website labeled Fancy Search. So this is how it got its name there. And then I took a pause. So it was just a pet project. And maybe I started to abandon it. And time passed and slowly led to the present days. But let's recap for a while. There are some things I did not mention. So the index only contains exposed values, so no types or type aliases, and the documentation comments are limited just to the first paragraph. And this is because it's an LMAP, so it's running in the browser. And I had to limit the index because every time you visit the website, it gets downloaded to your browser. And downloading, especially parsing, took a long time and completely blocked the UI. And not everything I had in mind was implemented, and I was always hesitant to add new features because it was my first AIM project, and the code really did not support adding new features. So this left me wondering if having the search was a good idea after all. And I actually stopped using it, and I learned a lot building it, but I felt it did not really help me anymore. But on the other hand, people used it, and they added issues and requested features on GitHub, and they used it to help other people on Slack. And I also had nice discussions about it at meetups or conferences. And AIM search was always somewhere in the back of my head because I had the feeling there was some unexplored potential. And after switching jobs some time ago and having some AIM search-related discussions there, I went back to the drawing board. But this time, I wanted to have some high-level goals to guide the development of the next version. So I asked myself, how can AIM search help? How can it help you as a single developer, your team, or maybe even the AIM community? And I came up with the following 3 points. So people who use the search should not only find things, but they should also learn something on the way. And I wanted to assist people helping other people. And finally, I want to research if AIM search could make you more productive. So at the moment, I'm in the process of porting the old code to a new code, and just to have feature parity and then to be able to add new features more easily. And the search is still implemented as an LMAP, but now embedded in a headless worker program communicating with the Node.js server via ports. And this allowed me to add much more data to the index. And the website is just a consumer of this API I'm exposing. And this leads to much quicker startup times. So what other changes could I add to achieve the goals I had in mind? So to assist in learning when using the search, I'm going to add explanations. So when you, for example, search for a list to list, this probably does not return any results, but we could display a note instead, mentioning that lists are homogeneous and that you need to define the type it contains. And if you search for a name of a record type alias or a name of a type variant, we could also show a note on top of the search that explains that AIM automatically gives you constructors for those types. And we saw earlier those fuzzy searches, and when results for those searches appear in the result, we could add a note just next to the result explaining those features of AIM, and this just makes it more discoverable. And I want to support advanced searches. So AIM is a functional language, but by design it hides some more academic concepts. But more experienced people might still be interested in, for example, which module implements specific type classes. So I'm extending the type we saw to support queries like that. And the current version only has basic support for type variables, so it works by the name of the type variables are reassigned to a new character by in alphabetical order. And this helps to find comparisons that are structurally the same. But I want to improve that by dynamically building up a mapping from type names, from names of type variables to actual types, and doing this in each comparison. And this helps in finding either more concrete or more abstract results. And this can help to see patterns because AIM hides the functional concept. This can reveal like functional concepts. Also, statistics are a great way to get an overview of the ecosystem, and especially in AIM because it hides those abstractions. And it doesn't have it. And we can visualize those statistics and to real patterns or to help package authors make informed decisions. So let's have a quick look how it looks now. So it's basically the same. You can search by name or by type signature. And one feature added is you can toggle the full documentation of the value. And I also have basic support for type class style searches. And now let's have a look at some statistics. So we have 752 packages by 366 authors. This is nearly 2 packages by author. And the major versions look like stable. So the APIs are mostly stable, but maybe it also means that packages are not updated. I'm not really sure. And the number of dependencies, the number of exposed modules is really low most of the times. And maybe this means that packages are wrapped around a specific custom type and exposing an API around that. I want to check this out. And what we see here, so the number of dependencies is low mostly, which is good. And there's one package that does not depend on any other package, and this, of course, is AIM core. And all other packages depend on it. And it's interesting that AIM JSON is that popular to me, and AIM regex is more popular than AIM parser. And the top 10 dependencies, of course, are from the AIM user official dependencies. And when we look at some type class searches, let me scroll down a bit. So I looked for and then like functions, and I only found 27, and I expected more, so maybe my search is not working really good. But what we see is most of those functions are called and then, and this for me is a sign that all the package authors think about their API design. And to help other people, I thought it would be nice to help those people, with the Slack bot, because we saw already that people use it on Slack to help other people. I implemented a prototype version. So I'm here in my private Slack, and I can just type in AIM search with a search, I press enter, and hopefully the server is working on internet working, and I get some results. And this is like super basic. I want to explore how more dynamic Slack features can improve that. So finally, the title of the talk contained the term productivity tool. What about that? And we already have feedback loops with the AIM compiler when we create or refactor code. But some other languages go a little bit further. And PureScript, for example, has built-in support for typo holes and a companion type-directed search. And Idris, for example, is also popular. It can, in this regard, it can even write code for you when you do type-driven development. And what if you could have something similar in AIM? So let's look at an example how this could be implemented with AIM search. So this is a type mismatch compiler error message. And the compiler tells us in a friendly way that it's expected in tag ID, but it can't tell you where to find such a value. And we could, so because the AIM app is now embedded in a headless worker application, we can create a CLI version of it and only put local project dependencies in the index and also pass the source code to have this available in the index as well. And then we could pass the error message and search for tag.id in this case. And yeah, the tooling could point you to actual values of this type or functions returning this type. And the IntelliJ plugin also now has its own time preference algorithm, and we could try to hook into that to not depend on this hack. And this idea is not new, so Chris Jenkins described it on his blog some time ago, type bombs in AIM, he called it. And would this make him more productive? I think it's worth exploring such a human-computer interaction beyond the already compiler. So what's the moral of the story? Personally, I learned a lot writing AIM search, making it public, and watching it being used. So having a real project is a good way to learn the language. And it's not only the language to get to know you, also the tooling ecosystem and community are important factors when to find out whether to invest in technology. And taking the next step and building something that is beyond just code takes time, and having goals helps shaping the product. And it's good that AIM's development takes its time. It's like a Zen garden in web development. And this also gives room for experimentation in the community. And we can take ideas from other languages to see if we can adapt those into AIM's ecosystem. And for a project like AIM Search, I was lucky to choose AIM because the language is small. There's one place to get the packages, and everything is documented. And there's little magic in the language itself, but the tour I took from writing AIM Search, for me, it still feels a little bit like magic. And the style and pace how AIM itself is developed might not suit everybody, and I felt this first with my pull request that got rejected. And but at the end, I strongly believe it's for the best, and it made me rethink what AIM Search is and should be. So that's my story. Thank you.
Thank you, Jonas. Are there questions?
Thanks for the talk.
Thank you.
How do you make sure that the documentation index is up to date with package?
So at the moment, I'm running it on CI. So every day, or when I publish a new version, there's a job grabbing all the documentation JSON files and creating a big JSON file out of it. Or it used to be like a big JSON file. We improved the performance a little bit by generating actual AIM code so that the parsing step is not needed anymore. The app, of course, then is much bigger because the actual data is in the application itself, but it helped with the startup times.
Okay, so thank you very much, Jonas.
Thank you.